Hi, welcome back. We're going to begin our next unit on rational functions and relations. We're going to start by doing some inverse problems, or actually variation problems. And there's three general classifications: direct variation, there's inverse variation, and there's combined variation. We're going to talk about all three, but inverse, this one is the one that's most closely related to rational and reciprocal functions. Okay, so while we're going to talk about all three, the inverse one is what we'll talk about more moving forward in the other lessons. So direct variation has a unique condition. When you look at the ordered pairs, whether it be in a table or on a graph, if you divide your y value by your x value, you always get the same number. So it has a constant ratio, okay? That number we call k is referred to as the constant of variation. So if you're given tables like we are here, this is easy for us to check to see if it's direct variation. We simply take our y value and divide it by our x value, and that would give us 7. And 7 divided by 1 is 7. And 14 divided by 2 is 7. And 21 divided by 3 is 7. And 35 divided by 5 is 7. So our constant of variation, k, is equal to 7. And since every ratio is the same value, this would be direct, okay? Because the y divided by the x is the same. That's what makes it a direct. All right, so why don't you try this video question and see if that represents a direct variation problem. All right, so here we go. I'm going to check my ratio y divided by x. That's 9/27. That's a third. That's 10/30. That's a third. And that's 20/60. So that's a third. So k is equal to 1/3, and it's direct variation because it's the ratio of y to x. For different types of variation, the k is calculated differently. So direct variation. Okay. Once we find k, we can write an equation that models the direct variation. So the first thing you want to do, like we did on the previous slide, is we want to find k by calculating y over x. Once you find k, then you're going to plug it into this. This is a direct variation form, so you want to remember this, and you want to remember the k. Right, these two things you're going to want to remember, memorize them, understand them, know how to get there. So then we would just plug whatever value we got for k in that spot in the equation. So let's work out an example. If x equals 4 when y equals 2, and we know that they vary directly because the directions will tell us how it varies most of the time, write an equation to model that variation. Well, we first have to find k. So we're going to take 2 and we're going to divide by 4. That gives us a half. And then once we have that, we're going to just plug it into our equation, y equals k times x. So y equals 1/2 times x. Okay, so go ahead and try the video question. All right, so if you did get that correct, write down what you did so that you can ask me about it. Now, suppose that we're asked to find a missing value in a set of ordered pairs, and we're told that it's direct variation. Well, again, we have to find k. So use the ordered pair that has both the x and the y value, and just take your y value and divide by your x value. So we get k is equal to 3. Okay, now in order to find this other variable, we're going to use y equals k times x, and we're going to plug in both the k value, and then we're going to plug in the x value. Okay, so I have y is equal to 3 times 30, 3 times 12, which equals 36. So y has to equal 36. So think about this. That says my ordered pair is 1236. If this is part of that direct variation, then the y divided by the x has to equal 3, and it does. So why don't you try the video question? If you get it wrong, write down what you did so that you can ask me about it. Now we're going to talk about inverse variation. Okay, so for every ordered pair in the function, instead of y divided by x being a constant, y times x or x times y is a constant, still called the constant of variation. Okay, so now if, say, you are given a table and it didn't meet the direct variation, then you would check the product of the coordinates, and if the product is the same for all your ordered pairs, then you have an inverse variation. So let's check this. So I have 15 times 2 is 30. 7.5 times 4 is 30. If you don't believe me, check it on your calculator. 3 times 10 is 30. 2 times 15 is 30. Okay, so my k is equal to 30, and since every product is the same, then this is an inverse variation. Inverse variation, okay? So why don't you try the video question and see if you get it right. Okay, so I'm going to check my products. 10 times 2 is 20. 8 times 4 is 32. 3 times 10 is 30. So I don't have a constant product of my x's and y's. So I'm going to say this is not a direct variation problem. You could also say it'll be like in the problems in your homework set, it'll say, is it direct variation, inverse variation, or neither? So that would be a neither. So the next thing we can do with inverse variation, once we find k, is that we can write an equation to model the inverse variation. Works the same way, you just have to choose the right relationship for k and the right relationship for the inverse variation. So what you need to know for inverse variation is, we've talked about this, k is equal to x times y, and then your function is going to be y equals k over x. Okay, so let's work a problem. If x equals 4 when y equals 2, we're going to write an equation that models that inverse variation. And we're told up here that they vary inversely. So that means k has to equal 4 times 2, which is 8. So when I plug it into my equation for an inverse variation model, I get 8 over x. So why don't you try the video question? If you get it wrong, make sure that you write it down so that we can talk about it. All right, let's now let's find a missing value in an inverse variation problem. It works much the same way as direct variation. Just remember that the only difference is that your formulas are a little bit different. The process is the same, but the formulas are knit together just a little bit differently. So in this problem, my k is going to equal 2 times 6, which is 12. So now I'm going to plug in k, and I'm going to plug in 3 for y, and I'm going to figure out what my x value is. So I get 3 is equal to 12 divided by x. So 3x is equal to 12, and x is equal to 4. Okay, so well, why don't you try the video question? All right, again, if there was a problem with that and you couldn't figure out what you did, make sure you write it down and you ask me about it when we meet tomorrow. Now we're going to talk about combination. There's a whole spectrum of combination. There's one particular combination variation that has its own special name, but combination variation is you generally have two or more variables, but they're varying in different ways. So generally you have 3 variables. Okay, so we're going to have, with joint variation, it's when you have one variable, say z, but it varies directly with two or more variables. So it would say something like z varies directly with x, y, and w, or z varies directly with x and y. Okay, so that means it's not just varying directly with one other variable, but it's varying directly with 2 or more other variables. So if we wanted to write a function, all right, that varies jointly, the way to figure out k is whatever variable is before the word varies, that's going to go on top there. And then everything that varies jointly with it is going to go on the bottom. That's going to give us our k. So let's figure that out. So we get k is equal to z, which is 24 over the product of 12 times 2 times a third. So if I simplify the bottom, I get 24 over 8, so that gives me 3. So that's what my k is. So then I take my k and I plug it into my equation. And it doesn't matter what order you put the w, x, y. Generally, it goes alphabetical, but if you didn't, it wouldn't be wrong. The last, the next combination, there's all kinds of combinations. You just kind of have to read the sentence, okay? Write a function that models z varies jointly with x and y and inversely with w. So whatever is, for these, here's how I like to do it. I actually like to start here with this equation. Okay, so anything that varies jointly with z, when you write it, you always have your constant of variation. Anything that varies jointly or directly is going to go in the numerator. Anything that varies inversely is going to go with the is going to go in the denominator. So then I plug the given values into this equation and I solve for k. I know it seems a little bit backwards in this, but for me it's always easier to remember, particularly with the combined variations. It's always easier for me to write it out like this first and then get to k. So I'm going to plug in 4 is equal to k. I don't know that, that's what I'm looking for, times 3 times a fourth over 2. And so I'm going to get rid of the 2 by multiplying both sides by 2, and I get 8 is equal to 3/4 k. 3 times a fourth is 3/4, and then I'm going to multiply by the reciprocal. So I get 4/3 times 8 is equal to k, so I get 32/3. is equal to K. All right. Then I plug it into this equation. So I get Z is equal to 32 over 3 x, y in the numerator and w in the denominator. Because x and y vary jointly, that means both of them are varying directly, and then w is varying inversely, so that has to go in the denominator. Okay. All right, the last thing that we're going to talk about is some applications. These are kind of fun. So it says a number of bags of grass seeds N needed to seed a yard varies directly with. So N equals, all right, I have a constant of variation. I know that for sure. Directly with A. So if it's directly with A, is A going to go in the numerator or the denominator? It's going to go in the numerator. Okay, and inversely with the weight of the bag. So inversely with W, does that go in the numerator or the denominator? It goes in the denominator. Okay, so my first thing I'm going to do is try and find K, and I'm going to use the remaining information to help me do that. If it takes 2 3-pound bags, so 2 bags, so N is equal to 2. What's the weight of the bags? Well, they're 3 pounds each, right? And then it covers 3,600 feet squared. Well, 3,600 feet squared, anytime you see feet squared, yard squared, that's area. So area has to equal 3,600. Okay, so we're going to plug that in. N is 2. So 2 is equal to, K I don't know, area is 3,600. And W is the weight of one of those bags, which is 3. Okay, so I'm going to solve, and I get 6 is equal to K times 3,600. So 1 over 600 is equal to K. Right? Now I'm going to plug K in and then the other information. So it says how many 3-pound bags. So what am I looking for? I'm looking for N. That's my question mark. So N equals, all right, my K is 1 over 600. So I'm going to do this, 1 over 600. And then area, I need to cover 9,000 feet squared. So I'm going to multiply that 1 times 9,000. And then what's the weight of each bag? Well, that's 3 pounds. So 3 goes on my denominator. And when I calculate that, it's like 9,000 divided by 1,800. And that gives me 5 bags. Okay, so we're going to work this problem set on Monday in class. So if you feel like you need to get a jump start or do a couple just to kind of solidify what you learn, and then check your process when you first get to class, that's awesome. Thanks for listening, and I will see ya.